Alright, hello everybody. In this video we're going to talk about chapter 7. So first we're going to see loose dot symbols, and then we're going to start making molecules. So let's go let's go back to our electron configuration table. Right, you remember that we got like the order is 1s2, 2s2, 2p6, 3s2, 3p6, and it goes on like that, right? And then it's going to be 4s2, 3d10. So if you have all electrons filled, so this is the order, right? For example, for a hydrogen atom, so let's talk about hydrogen. For hydrogen, we have one proton and one electron, so it's going to be 1s1 because we have just one electron. For sodium, we have 11 electrons, so let's work on this one. For sodium, we have 11 electrons. It's going to be 1s2, 2s2, 2p6, 3s1. So let's work on potassium, and potassium has 19 electrons, so potassium has 19. So I'm going to go 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So 2 plus 2 plus 6 is 10, 2 is 12, 6 is 18, and 1 is 19. Alright, so this is called electron configuration. These are the addresses of electrons. So for the hydrogen, I have one electron on the first shell, which is s-type, which is sphere. For the sodium, I got first shell, I have 2 electrons. On the second shell, I got s-type orbitals, and then p-type, right? And the third shell, I have only s-type. So for potassium, I get s-type in the first shell, I have s and p-type on the second shell, I have sp on the third shell, I got 4s on the fourth shell. So these are called electron configurations. So what is valence electrons? So we want to know how many electrons on the outermost shell, because protons and neutrons, they do nothing, as well as inner shell electrons. For example, for hydrogen, we have only one electron, right? So this is in the first shell. For sodium, I have 2 electrons on the first shell, I have 8 on the second shell, 1, 2, 3, 4, 5, 6, 7, 8 on the second shell, and I have 1 on the third shell. For potassium, I have 2 on the first shell, 8 on the second shell, this is 8, and this is 8 on the third shell, you can count, and this is the fourth shell, which is only 1. Okay. So valence electrons are the outer shell electrons of an atom. The valence electrons are the electrons that participate in chemical bonding. So inner shells, like for hydrogen doesn't have any inner shell, but sodium and potassium, they do, right? So for these two elements, the inner shell electrons do nothing, right? Okay, so protons, neutrons, and the inner shell electrons, they do not participate in chemical bonding. The only one participates is the outermost shell. So these guys right here. Okay. Alright, so let's see our periodic table, wonderful periodic table. So when I look at the periodic table, I see that hydrogen, sodium, and potassium right under each other, right? Okay, so we have the periodic table like this, right? And then here we have hydrogen. Let me show you, just a second, sorry. So we have hydrogen here, and I'm going to erase this part. Okay, so this is hydrogen here. This is sodium here, this is potassium. They're on the 1A, right? This is 1A on the periodic table. So what is in common here is that when I look at hydrogen, has one valence electron, right? The outermost shell electron. There is only one electron on the outermost shell. Hydrogen has just one, that's going to be it, right? For sodium, I have 2 inner shells on the first shell, I get 8 on the second shell, but I have only 1 on the third shell, right here. So sodium has also 1. When I look at the potassium has also 1. Alright, so all these elements in the same group, they'll have the same configuration, right? Only one valence electron. When you do this 1s2, 2s2, 2p6, whatever electrons you have, right? So if you have an element on the 1a, you'll end up having ns1 configuration, like hydrogen is 1s1, sodium is 3s1, and potassium is 4s1, right? Okay, and the number of valence electrons will be 1 in all of them. So we're going to make our life easier by showing those electrons next to atoms. For example, for hydrogen, I'm going to show with a dot. this electron, the valence electron. For sodium will be the same here. I have just one valence electron. So I'm trying to show which electrons are participating in bonding. So then I can do some calculations with it. So for potassium, I'm gonna just one electron as well. Okay. So let's look at here. This is called loose dot symbols. All right, loose dot symbols. For hydrogen, right here, I have one electron. For lithium, I have one electron. For sodium, I have one electron. For potassium, I have one electron. I did sodium, potassium, and hydrogen. Lithium will be the same. So let's do lithium here. Then you will see how it's different. Lithium has 3 electrons, right? 1 is 2, 2 is 1. See, right here, the same number. The number of valence electrons is going to be 1. Okay, so we are going to show with a dot. So those valence electrons will be shown as a dot around the symbol of the element. So let's do here like beryllium. All right, so beryllium has 4 electrons, right? I have 1 is 2, 2 is 2. So this is the first shell, this is the second shell. On the second shell, I'll get 2 electrons. So how many valence electrons do I have on beryllium? You can pause here and you can answer. That's going to be 2, right? Because on the first shell, I get 2, that's the inner shell. On the second shell, I have 2 electrons, so beryllium will have 2 valence. So I can show like this, right? Beryllium has 2 electrons. We want to show the valence electrons around the symbols of elements, so we can do some calculations with it, okay? So let's work on oxygen, for example. Oxygen, I'm going to erase here, then I'm going to go with more elements, okay? Let me erase here. Here we go, right here. So here's the oxygen electron configuration. Oxygen has 8 electrons, right? And 1s2, 2s2, 2p4. On the first shell, I got 2 electrons. On the second shell, I have 6 electrons. Total, 2 here and then 4 here, total of 6 electrons, 3 and 6. So how I'm going to show those electrons? Well, the loose dot symbols was going to be oxygen, right? And I'm going to show oxygen. So 1, 2, 3, 4. I'm going to put each electron around every side of the symbol, and then I'm going to pair up from the 4th electron. So here I got 6 so far, so I can do 7 and 8. Okay, you don't have to be very accurate with this. I mean, you can have the dots on the left, on the right, but it's better to be same throughout the course, right? So this is how I'll do it. All right, so here we got 6 valence electrons on oxygen, right? We got 8 total, but here we have only 6 of them available for reactions because the outermost shell, the valence electrons are the one participating in chemical bonding. All right, so here, once you do all the valence electrons, you'll be getting these numbers, right, or these symbols. For lithium, it's going to be 1, rubidium, cesium, and francium. They are all going to have 1 valence electron. And for noble gases, I get 2, 8, 8, 8, 8, and 8. Okay. So loose dot symbols for all these elements here. And now we're going to work on how to use these dots here to do some calculations, right? Okay, so let's do this practice problem here. We want to know what is the loose dot symbols for chloride ion, right? So let's do the chlorine first. Chlorine is not ion here, so I'm going to do 1s2, 2s2, 2p6 makes 10 total, 3s2, 3p5. So 10 plus 2 plus 5 is going to be 17. That's going to be the electron configuration of chlorine. But here, the question is asking not chlorine, it's asking the chloride, right? It's asking chloride. So for chloride, how many electrons do we have in total? We have 18 electrons, right? Gained 1 electron. So these numbers right here, they are electrons. If you have an atom which has 17 protons and electrons and gains 1 electron, you'll have 18 electrons. So you'll work for 18 electrons now. 1s2, 2s2, 2p6, 3s2, and 3p6. So here I'm going to look for how many valence electrons I have. I have 2 on the first shell. I have 8 on the second shell. I have 8 on the third shell, right? I have chloride, negative 1, 2, 3, 4, 5, 6, 7, and 8. Total of 8 has a negative charge. This is not it, not it, not it, not this one, not this one either. So I'm looking for B here. All right. So this is how we do loose dot symbols. Okay. On next video, I'm going to go over how to do ionic bonds and covalent bonds. See you in the next video.